So we're going to look at the basic parabola. So that's the mother of all quadratics. Okay? The main quadratic function. So the basic parabola is called y equals x squared. This is the origin. Okay? This is where all the other parabolas come from. Okay? So we know it's a quadratic function because it has a square on the x. Yes? Degree 2? All right. So if I give you the x values, -4, -3, -2, -1, so on until 4, I can find my y values. So if I plug in this, that's going to be -4. It's -4 squared. Positive 16. How about -3 squared? -2 squared. -1 squared. 0 squared. 1 squared. 2 squared. 3 squared. And 4 squared. Okay, so all what I did right now is I plugged in the x values into my equation. If I do the first difference, so I have 9 minus 16, what do I get? -7. 4 minus 9. 1 take away 4. 0 take away 1. 1 minus 0. 4 minus 1. 9 minus 4. And 16 minus 9. Is your first difference constant? No. So I must find the second difference. I do the second difference. So -5 take away -7. Positive 2. -3 take away -5. 2. -1 take away -3, that's 2. 1 take away -1, that's 2. 3 take away 1 is 2. 5 take away 3 is 2. 7 take away 5 is 2. So in this case, my second difference is constant, right? Which I knew because I know it's a quadratic function. We call the first and the second difference, or we call the differences, we call them finite difference. So if you see that question, if the question says find the finite difference, that means you're looking for your first difference. And then if it's not constant, the second difference. Okay? It's called finite difference. Okay, if we're going to plot, what are we going to plot? What are we going to draw?
The values of x and y.
X and y. Okay? So I'm going to have to draw the x and y. I might not be able to fit everything, but let's try.
Good morning, staff and students. Sorry for the interruption. There is a Durham College representative here for about an hour in the front foyer. So if any of you have any questions about Durham College programs, you're welcome to come and ask your questions in the front hall. Thank you.
Actually, what I'm going to do, instead of going up by 2, because I'm going to explain something, and I don't want that, so I'm going to go up by 1. Yes, I'm not going to be able to fit everything, but that's okay. All right, so my first value was -4, 16. I can't fit that, so I'm going to go to -3, 9. Okay, so -9 is right here. Then I have -2, 4. I have negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So you see that looks like a quadratic function, and it should look like this. Do you have any questions about how I drew this, how I graphed it? We're good? So let's summarize the property of the basic quadratic relation. So what's your vertex, or where is your vertex? 0, 0. Yeah? So the vertex is at 0, 0. What do we call that point? It's called the origin, right? Because this is where the x and y intersect. What's your optimal value? It's y equals 0. And it is a minimum or max? Minimum, because it opens up. The parabola opens up. Where's your axis of symmetry? X equals 0, yeah? It runs through this, yes? And we call that the x is symmetrical about, do we call that the y-axis? It's not going to always happen. Just in this case, because your vertex is on the y-axis. So the graph is symmetrical about the y-axis. So that means if I fold the graph over the y-axis, they're going to match. How many zeros do you see here? How many times does my graph intersect the x-axis? 1, right? The only point of intersection is right here, right? Because this is my x-axis, right? My graph is intersecting the x-axis at what? 0, 0, right? So it's either you can write it as the zeros of the relations are, you can say x equals 0, or you can write the point, okay? So this. Or you don't have to do both of them. You can pick. Now we're going to look at what we call the step pattern. Okay? So the step pattern is going to be your best friend to graph quadratics in vertex form specifically. So the step pattern is the following. You're going to start at the vertex, which in this case the vertex is 0, 0. And then to go to the next point, so look here. To go to my next point, what did I have to do? How much did I have to go up by, and how much did I have to go over by?
1 and 1.
So I had to go up by 1, over 1, yes? And then go up 1, over 1 to both sides because of the symmetry, yes? So I started at the vertex, I went up 1, over 1 to either sides because of my symmetry. Now look at the next point. How much did you have to go up by for the next point? 3. So if you count, that's 1, 2, 3. Again, over 1. Again, if I go to this point right here on the left, and I go up 1, 2, 3, over 1, I'm going to get to my next point. How about to the next point. How much do I have to go up by? 1, 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Okay? So the step pattern is called 1, 3, 5. The step pattern is going to be always 1, 3, 5, but it's going to be multiplied by an A value, which we're going to talk about in the next in this lesson.
Step pattern's the first differences.
The step pattern is the first differences. Yes. Okay? So, step pattern. It is 1, 3, 5 if I do not have what we call a vertical stretch, which we're going to talk about. But with a vertical stretch, it's going to be A times, remember this, A times the 1, 3, 5. Okay? We'll talk about this in a bit. Okay, so if you see here, you go start at the vertex, you go right one, up 1 to the right 1, up 3 to the right 3, and up 5 to the right 1. And then you can do the same thing on the left side. Okay. Now here's what I want you to do. You have phones that have internet. Okay, I want you to open your phones and I want you to go to Google and type Desmos. Desmos spells D-E-S-M-O-S. D-E-S-M-O-S. You're gonna see Desmos calculator. You're gonna click on that. You can download the Desmos app, but for now, just let's use the online version. Okay? So what I want you to graph on Desmos, I want you to graph y equals x squared. So I am going to go to Desmos as well. And then you should have the calculator, or not the calculator, the keyboard. What you're gonna write here, you're gonna write y equals x. If you guys see this button, that's the square button right here. If you want to use any other power, you're going to have to press this button. But in this case, I just have to graph y equals x squared. Y is right here. So y equals x squared. Are we all on the same page? All right. You guys get a graph that looks like this?
Teacher, how do you put x again?
You see this one?
Yeah.
And then press the square button. This one, the one that says a squared. Okay, now you see that my vertex is at 0, 0. You see that my next point is at 1, 1. You see it, it's right here. If I can find it, here it is. Okay. All right, now, the next question is asking you to find or graph y equals 2x squared. So I'm going to go and I'm going to press right under this so it opens up a new box. And I go y equals 2x squared. What do you notice here? Same. It's narrower. Yeah. Okay. So it has the same opening up, has the same vertex, right? It's just narrower. Can you guys tell me what's the next function in your table? So that is y equals 0.5 x squared. Again, I'm gonna press under it, so it opens a new box. Y equals 0.5 x squared. Now, can you compare the new green function, which is a 0.5 x squared, to the original one, which is the red one? Wider. Okay? So it's wider. All right. How about your vertex? Still the same. How about your axis of symmetry? How about your optimal value? How about the direction of opening? Is it still opening upward? Good. So, does anyone have an elastic band? If I don't find one, can I borrow? Can I borrow it? It's okay, I need an elastic band. You will get me one? Yeah. From where? Office? You can download the app, yep. Okay, so if we're going to describe the blue function, which has a value of 2 in front of it, we're going to say that it is narrower, right? But if we're going to describe the green function, which has a 0.5 multiplied by the x squared, we are going to say that it is wider. Okay? So what made the difference is that value that is multiplied by the x squared. Do you guys agree with me? Right? So if I'm going to, I'm just waiting for the elastic band, but if you think about it this way, you have the elastic band, which is right here. Perfect. Thank you. So that's my original elastic band. If I want to make that elastic band narrower, what do I do with it? Which way? Stretch it which way? Up, right? So I have to stretch it up. When I'm talking up, what do I call this? Vertical or horizontal? Vertical, right? So if I want to make this original function, right? If I want to make it narrower, right? Skinnier, all what I have to do is I take it and I stretch it vertically. Guess what we call that transformation in math? Vertical stretch. Okay? To make something narrower, you vertically stretch it. Okay? So what's happening is that 2 right there, that's multiplied by the x squared, is causing my graph to vertically stretch. I'm just looking for my... Okay? So that 2 that you see multiplied by the x squared is causing my original function to vertically stretch. Okay? Now, I want to make this wider. What do I do with it?
Stretch it to the side.
Stretch it to the side, or if I take it and I actually vertically compress it. So if I press on it, right? So I take this and I press vertically on it, it makes it wider, right? So we call that a vertical compression. Okay? So for this to be, because this is wider, what's happening is that 0.5 is going to vertically, so vertical compression. Okay? Now you're going to say to me, is this always going to happen? When am I going to have a vertical compression and when am I going to have a vertical stretch? I'm going to give you another one here. Okay? So what if I don't have a 2, I have a 3x squared? What if I have y equals 3x squared? Is it vertically stretched or vertically compressed? Vertically stretched. If I have y equals 4x squared, vertically stretched. Now, let's use values that are less than 1. So y equals 0.3x squared. It's wider, right? So it's vertically compressed. So what's the correlation between the values of A? Yes?
Well, as close as the vertex is stretched, as apart from the vertex is compressed.
But what can you tell me about the A values? If the A values are,
The more stretch.
okay, so as long as the A value is greater than 1, so it's 2, 3, 4, 1.5, greater than 1, I am going to have a vertical stretch. If the value is between 0 and 1, so 0.5, 0.3, 0.7, 0.8, so 0 point something, then I'm going to have a vertical compression. Okay? So, we're gonna write all this down. Okay? So, in this case, what is the value of A? 2. Which way was the opening of the graph? Up or down? What was your vertex? And then the axis of symmetry is x equals 0. Compared to the shape of x squared, how did you compare? It was skinnier, but we're not going to say skinnier, right? We're going to say it was vertically stretched. I'm just going to put it in bracket. Don't write it on a test. I just want you to remember why. Okay? What's the value of A here? 0.5. Which direction was it opening? What was the vertex? What was the axis of symmetry? X equals 0. And then it is vertically compressed. So in this case, it was wider. Now, have you guys tried the negative 2x squared? So if I go back here, I'm just going to erase these ones. So what happens once you put the negative right there? So y equals negative 2x squared. What did you notice? The open changed to down. Did I still have the vertical stretch? Yes. My vertex still at 0, 0. The only thing that happened is I have a reflection. Okay? So what happens is like I put a mirror and then it's reflecting through the x-axis. So it's called a reflection. Okay? Same thing if I have y equals negative 0.5 x squared. Right? So that's the same thing as this one, except it's reflected through the x-axis. Okay, so if I'm going to write this down, so what would I write? What's my A value? Negative 2. Which way does it open? Vertex. Axis of symmetry. And it's reflected and vertical stretch. You're going to see me writing vertical stretch as VS, okay? VS. And then my next one, my A value is negative 0.5. Which way does it open? What's my vertex? Reflected and vertical compression, which is VC. Yes. Reflected is one of the transformation. It's a reflection through the x-axis. Okay, so we know if A is negative, then it's going to open down. Okay? This is how we're going to remember this. If A is negative, what does N open? In what direction N open? Right? And then if A is positive, right? Positive means happy. So you're going to open up. Yeah, on the N. Or on the V, yeah. But both of them have V, so that's why I don't do that. Yeah. That's right, but both of them have V, that's why I don't do that. But I always say positive means happy, and then opens up. But once you can do the negative, it's good. All right, now, let's put it all together. The sign of A indicates what? The direction of opening. It indicates the direction of opening. Why is this not here? When A is positive, the parabola opens up, and then when it opens up, it has a minimum or max? Minimum. Right? Up, min. When A is negative, the parabola opens down and has a max This is known as a reflection. The value of A describes the shape of the parabola, so is it if it's going to be wider or skinnier. Regardless of the sign, okay? The negative only indicates reflection. You don't, when you have a negative, you just say reflection and forget about that negative idea. Okay? So when A is between 0 and 1, the parabola is wider than y equals x squared, and we call this a vertical compression. When A is greater than 1, the parabola is narrower or skinnier than y equals x squared, and we know that as vertical stretch. So that A value that's multiplied by the x squared is going to tell you the direction of opening, and it's going to tell you it's a vertical stretch or vertical compression. Okay? And that A value is the one that's going to be multiplied by your step pattern 135. Okay? I will get you guys to do this in a bit. In the meanwhile, I want to go to the next page. And the question is asking you for this one to state the transformation and graph. Okay? So first you have to state the transformation. This is what your graph is going to ask, what your question is going to ask you most likely. State the transformation. So when I look at this, remember your original function is y equals x squared, yes? So compared to y equal x squared, this is going to have a what? So it's going to be reflection because it's a negative. We say reflection in the x-axis, and it's going to have a vertical stretch. Okay, so I stated my transformation. Okay, the question says state the transformation. These are my transformations. Reflection because it's negative, reflection in the x-axis, and my second one is a vertical stretch. Are we okay with this? What would be my vertex?
X equals
So
0.
0, 0, yeah? 0, 0. Remember, we looked at this. We looked at that the A value, if you look back here, the A value never had any effect on my vertex. Okay? So my vertex for this is going to still be 0, 0. Now I need my vertex because I need to be able to draw my next points. What did we say the step pattern is? 1, 3, 5, but it's going to be multiplied by the A value. Okay? So the step pattern is 135 multiplied by A. What's my A? So my step pattern is going to be -2, -6, -10. So -2, -6, -10. So that being said, I'm going to start at my vertex. I'm going to start at the vertex, which is at 0, 0. And a subparent tells me -2. What does -2 mean? 2 down, and then 1 to the right and to the left. Okay? So from here, from the vertex, I'm going to go 2 down, and then 1 to either sides. So that's going to be my next point. Do we understand that? Now, how much down do I need to go from there? 6. That's why it says -2, -6, -10. Because that means you're going to have to go down 6 over 1. Okay? So, this means down 2 over 1. Down 6 over 1. Okay, so from my next point, I'm going to count 1, 2, 3, 4, 5, 6 over 1. So that's going to take me to this point, which is -8, 2. And -8, -2.
I have a question.
Mm-hmm.
Are we following the same pattern which we are following over here? Like that?
The pattern was 1, 3, 5. But because of my vertical stretch, it's causing it to be multiplied by 2. So it's not 1, 3, 5 anymore. It's 2, 6, 10.
Okay, so how did we, when we went down to, how did we figure out that we have to go 1 on both sides?
It's always 1 on both sides.
Always? Okay.
Okay? And if I want to continue here, how much do I need to go down from this point? 10 down over 1. Okay? I probably won't be able to fit this one, but this is enough. 5 points is good enough to be able to draw my shape. Okay?